Welcome to video clip 3.2, in which we investigate structural soundness. In 3.1 I already discussed a little bit soundness, and soundness is a generic correctness criterion for process models, formally specified using PetriNet. It has been developed by Wil van der Aalst of the Technical University in Eindhoven. And in this course we transfer soundness to the level of bpm_n. So we use the soundness criterion and apply it to the bpm_n level. We have seen also in video 3.1 that this process model exhibits an anomaly, behavioral anomaly. If the invalid amount decision is taken, and the send update invoice is executed, then receive payment is executed again, but then this end join cannot fire because there's just one edge that is signaled, and an edge and an end join, as we know, can only be signaled if all incoming edges are signaled. Therefore, we have this a deadlock situation. The process gets stuck, and this we consider unsound behavior. However, soundness assumes that a process is structurally sound. So structurally sound is a structural property of PetriNets, and we can also apply it to process models in bpm_n as follows. So a process model is structurally sound if it has exactly one start event, and the start event is called I. I is for input of the process, or the process has one input. And the process model has exactly one end event, O, and that is for process output, where is the output of the process, where we find the output of the process. And each node in the process model is on a path from I to O. So starting from I, we can traverse the nodes of a process model, and all paths, say, of maximal length end in O. That is the definition of structural soundness. And structural soundness is a necessary condition for soundness, but it is not a sufficient condition. So if a process model is not structurally sound, it cannot be sound. So therefore, we need to tackle structural soundness. If we look at the process model we've seen so far, most of them, I think, were structurally sound. So the one you see here on the top of this slide is actually structurally sound. So why it is structurally sound, using the highlighter again, there is one input event I, one output event O, and all other nodes, so all other activity and all other gateways, are on a path from I to O. So let's see whether that happens. Yeah, that's a path, but also we have this path, and also we have this path. Yeah, so all nodes are on a path from I to O. So structurally sound, this model is structurally sound. However, some of the process model we've been looking at are not structurally sound, like the one we see here on the bottom. And that's very simple, very easy to see why that is, because here we don't have one output, but we have two outputs. So that not all events, even if I say, well, that's my output O, and then there are nodes that are not on a path from I to O, because there are these two activities. So if there are two output events, then the process model is not structurally sound. So process models with multiple end events are not structurally sound for the reason I just explained. And that means that all these process models cannot be sound as well. So but if we look at the process model, and we looked at this insurance claim process model for some time now, it is behaviorally correct. We would not say that there is a deadlock, the process model is incorrect, it has some behavioral anomalies. We would not say that. So we need to transform these process models to structurally sound process models to be able to analyze then soundness. Because this structurally unsound process model has correct behavior. We see that because it's so simple. However, if it would be more complex, then we would not be able to analyze it just by looking at it. We would need to use more advanced techniques like the one we will discuss in this week. Therefore, an approach we like to propose is that we transform these process models to structurally sound process models without changing their behavior. And then we could use the structurally sound process models to analyze them, and then we can say, well, either the process model is sound or the process model is unsound. To start our formal analysis, we can get rid of a number of things that are not important for the formal investigation. For instance, we could remove the event information. We could also remove the event labels and also the roles involved. The activity labels we can keep, because then we have also a feeling what happens in the process and what are the activities from a more business perspective here. Okay, now we transform structurally unsound process models to structurally sound process models. We assume that all end events are exclusive. So in each process instance, either this end event occurs or that event occurs. In no process instance or in no trace generated here, we see more than one end event. Yeah? So all end events of the process model are exclusive. There is no trace in which more than one end event occurs. If this assumption is not met, the transformation introduces errors. Okay, so let's try to come up with an approach to change a structurally unsound process model to a structurally sound process model. And that's quite easy indeed. So I like to sketch, or let's put a bit more on the upper part. We have here an activity A. Then we have an exclusive gateway, so an XOR split. Either I need to do a B or I need to do a C. There's one end event and there's the other end event. Okay, and obviously it's clear that we have traces AB and or AB, the top end event, and AC, the lower end event. So the end events are exclusive in this example, so the assumption is fulfilled. Okay, so I use the eraser to show now the transformation. I will transform this process model to one that is structurally sound. What I do is I remove the two end events. I remove the sequence flow. And I add another exclusive gateway, connect this, and create a new end event. And that's all. So that's very simple. So the algorithm is we first delete the end events. We introduce one new exclusive gateway that joins the end event branches, so that joins these two branches, and we introduce a new end event. And that's how we can make sure that a structurally unsound process model will be structurally sound. Okay, we mentioned that we do not change the behavior. That's from a formally precise point of view, that's not correct, because we end the behavior in the sense that we don't have these two different end events, and we have one new end event created. So there is, from a formal perspective, that's not entirely true, but from the behavior of the process, from the activities, we really do not change any ordering, or we do not change anything by this transformation. And also, if there are behavioral flaws in the process model, we do not change these behavioral flaws by introducing this transformation, which is, of course, important for us, as long as the assumption that I was mentioning is met. Still, I like to notice that the different outcomes of the process are no longer represented explicitly in the process model. You might remember the guideline that we had, that each possible outcome of a process should be represented by one dedicated end event. we lose somehow this information in the analysis. However, we are not interested, we will not use these modified models afterwards, that will not replace it. This transformation is just used to analyze the process model that we had, that we use for our discussion and that we use for our project. So we will not work afterwards with the transformation. The transformation is purely for the purpose of analysis of the model, and therefore getting rid of these different output or end events is perfectly okay. All right, so the same applies to start events. Almost the same applies to start events. We sometimes see process models that have multiple start events. You remember also our modeling guideline that you should not have multiple start events. Still, in some cases, it's useful to have them. And even then, we have the problem that the resulting process is not structurally sound because it has more than one start event. So a typical example that we see is that there might be different ways of starting a process using different media. So here we have 3 start events. So the claim can be received by surface mail, or the claim can be received by fax message, or the claim can be received by a website. So the customer can use the website to fill the claim and to start the process instance at the insurance company. Here we have a join that joins if the claim is received by surface mail or by fax. I need to do an additional manual activity, register claim. I need to first register the claim. And if the claim is received by website, I can just start with deciding on the claim coverage because data is already in the systems and I don't need to register that explicitly. So that's an example that the type of example that we sometimes see. And also here we need to have a transformation in order to make these types of process models structurally sound. We do that by creating a new start event and an exclusive gateway. So it's similar to what we did at the end of the process, we did in the beginning. Also here, an assumption is that the start events are alternative, which is also an assumption by the bpmn standard, also mentioned in the bpmn standard. So in this start event needs to be connected to all alternative start events, or the gateway needs to be connected to all alternative start events, which thereby become intermediate events. So in the previous example, you will remember that we had 3 options of receiving the claim, by surface mail, by fax message, or by website. And so there is a decision here. We have modeled this as a decision, either that or that or that. And then the process continues exactly as we've discussed before. So all traces that are created by the original can also be created here. We have also here, from a formal perspective, one additional event, so the start event, which is, so we can formally say that it's not exactly the same behavior, but from an application usage point of view, we can still say that this is okay because the order and the behavior related to the events, to the other events and to the activities is not changed by this transformation. All right, good. So we now made sure that we transformed the process model which is structurally unsound to a process model which is structurally sound. However, as already mentioned in the end part, this transformation is only for the purpose of formal analysis, for checking soundness. The process model is not very useful, mainly due to the also magic decision in the beginning. So here in the example we have, in the beginning we have this decision. I was briefly mentioning that. Who should take the decision? That's not really a decision that is part of the process. So either I receive it by surface mail, by fax, or by web form. And therefore, there is not really this decision in the real process. But still, for formal analysis, it is fine and it is, let's say, useful and important to have a structurally sound process model to start with. All right, this concludes video clip 3.2, in which we investigated structural soundness. Behavioral analysis requires structural soundness as prerequisite. Structural soundness means that each process has a single start event called I, a single end event called O for input and output of the process, and each node of the process model is on a path from I to O. Formal analysis abstracts from labels and roles. And we have seen that process models with multiple start and multiple end events that are alternative can be transformed. And therefore we showed how we can transform an unsound, structurally unsound process model to a structurally sound process model.